Okay, inside the hidden, okay, hidden the multiple number of neurons available. Okay, so inside each and every neurons, there are three units available. Okay, three parts available. So the first one is um, activation functions. Um, then weight and bias. Okay, we will talk about the bias later, guys. Don't worry. So first, the process is like this. Okay, so you are going to given the data to the input layer. The input layer passes, say for example, you are going to pass the data uh, numbers like 5 and 10. Okay, so here the 5 is directly the input layer 1. First neuron passes the 5 here. Okay, and there is some random weight, guys. The weight may be 0.8, 0 to 1. Okay, there is a technique called weight initialization. We will talk about the later. So for right now, just assume there is a weight. Okay, 0.8. So this 5 is multiplied with this point 0.8, and it's going to be to the next neuron, hidden layers first neuron here. So this, okay, I'll just type like this. Okay, so I'm just take this as a x1, input x1, input x2, and the 0.8 is w1 weight. Okay, so here the input is, here the input is 5 into 0.8. Okay, means x1 into weight w1. Okay, so like that here x2 into w2. So here also x1 into w2, and here x1 into w3, like that. So totally the formula is summation of x, which is equal to I to the power of n. Okay, xi your input. Okay, I which belongs to 0 to n number of neurons, and wi. And additionally there is a one term called bias, it is b0. We will talk about this bias later, guys. Okay, then you will understand clearly. Okay, so this is the entire operation of the hidden layer. Okay, this formula. Okay, so all the inputs is collected from the input layers and multiplied with the respective weights and passed through the activation function. Okay, activation function we will discuss in this upcoming sessions. Okay, so activation function is nothing, it's a firing unit. Okay, so say for example you have activation function like this is a relu. So if your input is 0.5, then output also 0.5, like that. So it passes, the activation functions provide one y output. Okay, so this value, this y value, so this is input value which is collected from this place. Okay, and for the respective y value is fired by the activation function. This value, activated value, sent to the output layer. Okay, the output layer calculate the probabilistic value of the all the inputs. Okay, all the inputs of the output layer. So finally it's provide the output which probability, which unit is highest probability. Okay, so this progress is called feed forward propagation. Okay, if you not understand, no issues. This is the overview of neural network. We will discuss one by one elaborately. Okay, so this is the overall neural network. Okay, so why it is necessary? So what is the purpose of neural network? Okay, so in real time, so if you want to translations, like you are going to the one place, there is a Spanish word. You don't know Spanish, but if you want to, if you go to the Google, there is a image translate. There is a language translator. You just take a snap of the Spanish word. It will give the respective English or Tamil words, right? Translated words. So these translations happens based on the neural networks, and weather forecast, right? If you go to the Google, there is a weather forecast. So this weather forecasting based on the neural networks only, based on this weather forecast, you can able to understand what the next week temperature, say for example here, you can see Friday, Saturday, next Tuesday, the temperature is a 41 degrees Celsius approximately. The wind is maybe 14 kilometer per hour. Okay, so like that you can estimate. So like that you can understand the predictions of the weather in a particular region. So this weather forecasting happened by the neural network. Okay, time series. Okay, so image problem, language translation problem, time series problem. So these three problems are ultimately heavy, which cannot able to handle by the machine learning algorithm. So we need a separate architecture, that is a neural network, but that is not a that is not a picture. So neural network is ultimately it's coming from its base of the artificial intelligence. It started from 1856. Okay, so fine. So this is what neural network is nowadays. So we can use for weather forecast, image predictions, uh, language translation. So for everywhere, the neural network is ultimately used. It's a subset of machine learning. Okay, fine. Now, okay, now we will directly go to the concept. Okay, so okay, so the important thing of neural network is how neural networks works. The what is the purpose perception of this neural network means, you know, this architecture is inspired by the human brain. Okay, so the entire neural network architecture is inspired by the human brain. So our human brain is uh, connected with multiple neurons. Okay, like these units, so these units. So okay, so so how our human perception works, say for example, if you in the kid, okay, the kid who is not seen the fire before. Okay, so at the stage of 1 or 2 age, if the kid doesn't know this is fire, this is heat surface, right? If kid touches the heat surface, then he feels the heat, the heat kid feel the heat. So the human brain stores, oh, this is heat surface. Next time we won't touch the surface, right? So this is what human brain works. The neurons, um, it's the human brain stores the experiences. Okay, stores the experiences. Whether they want to touch the surface or they don't want to touch the surface, they want to see the picture, they don't want to see the picture. Okay, like that. Okay, so you can say you just take on doctor. So the doctor 5 years, the doctoral students 5 years they read books and doing experiments, um, doing anatomical experiments, doing some basic operations or sample operations. So these five years learning experience is stored into the human brain. So after 5 years, he is going to take actions against. He is going to take actions like he is going to give the medicines. He is going to suggest the prescriptions to the patients, right? So, so this is how human brain works actually. So this is not a biological class. I can't able to give the biological demonstrations, but this is the way you just understand how the human brain works. That's all, right? So this is the basic perception, basic inspiration for invention of the neural network. Okay, so now go to the class. Now going to the presentation. You can see this is the biological neuron. This is how the human brain is constructed. Okay, so the human brain has a billions of neurons, billions of interconnected neurons. Neurons are interconnected nerve cells in the human brain that are involved in processing and transmitting chemical and electrical signals. Okay, so ultimately the experience is stored based on the electrical and chemical pulses. Okay, so here you can see there is a input signals, there is a dendrites and cell nucleus and axon pipe and synapses. Okay, so input signals, it's connected to the dendrites are connected to the nerve cells, right? Dendrites are branches that receives information from other neurons. Okay, so basically the human nerves is connected to the dendrites. the other dendrites are connected to the other neurons. Okay, millions of neurons. Okay, cell nucleus is process the informations. Okay, or store the informations. Then this axon cable send or transmit the information from the cell nucleus to the synapse. The synapse is the connection connected to the other neurons or nerve cells. Okay, so this is the neurons. Okay, this is the basic biological neuron. So the input signals are sent to the dendrites. These dendrites receives the information and passes to the cell nucleus. The cell nucleus process the information, and this processed informations are transmitted through the axon pipe. This axon pipe, the synapses are collected the information from the axon pipe and sent to the nerve cells, or you know, your hand, your leg, your eye. Okay, if suppose say the example scenario, the input signal is heat. Your one person is going to touch the heat surface. Okay, the heat informations are received to the dendrites, and dendrites send the heat information to the cell nucleus, and cell nucleus understands, oh, this is heat, my finger is going to burn. So this information, this processed information is going to transmitted by the axon pipe. This axon, the snaps collect the information from the axon pipe. Then this snaps understands, this snaps understand, this snaps is going to give the command to your finger. Hey, this is heat surface, man. If you touch the heat surface for the upcoming 2 minutes, your finger will burn. Then the human immediately pull up their finger, right? So this is how the neuron systems works, right? So this is the inspiration of the neural network. The entire neural network, CNN, RNN, or entire deep learning. So these are all the called deep learning. Okay, so these deep learning algorithms are inspired by the biological neurons. This is how biological neuron work. Same way we are going to create the neural networks. The neural networks also going to work with this way only. Okay. Any doubt, guys? Any doubt on the biological neuron part? For the upcoming sessions is maybe you will understand. But if you have any doubts, you can ask me. So my first question is, my voice is clear, right?
Yes, sir.
Okay. Fine.
Yes, sir.
Okay, that's fine.
Yes, sir.
Okay. Now the comparison between the biological neuron and the artificial neuron. Okay. In the neural network, all the neurons are called artificial neuron. Okay. Fine. So the history. The researchers Warren, McCullough, and Walter Pitts. So usually in the deep learning term, they are called McCullough-Pitts neuron. McCullough, it's a one researcher, one mathematician, and Walter Pitts is another mathematician. So they come up with the study, the biological neuron and artificial neuron comparison in the 1943. Okay, that is called the MCP neuron or McCullough-Pitts neuron. Okay, so the input signals here, same way, the artificial neuron having a multiple inputs. Hello. Just unmute your. This is basic manners, guys. This is basic manners. Just unmute the systems, please. I don't have a control, so please cooperate. Okay, so yeah, this is the comparison between the biological neuron and artificial neuron. This comparison is derived by the McCullough-Pitts, Walter Pitts and Warren McCullough in 1943. Basically, this artificial neuron is also called as McCullough-Pitts neuron. Okay, so they described as such a nerve cell, a simple logistic gate with binary output. Okay, say here also. So the input signals, here multiple inputs. The cell nucleus, here there is a neuron. Okay, there is a neuron, or this is a nucleus part. You can say as a activation function. Okay, then axon pipe, output signals. So here output signals. Okay, so here output signal, you just understand the heat surface. Your hand in the heat surface, then your brain is going to give a command to you, hold the finger or take the finger, right? It's a binary. If you want to touch or untouch, there is a two type of output, zeros or one. Take a hand or hold the hand, right? So that is the logic gate. Okay, simple logic gate. In out gates, input output gates. Okay, just understand binary outputs only. But we can use artificial neuron to the you know multi-class classification as well as regression also. But initially in 1943, this is used only for the binary problems. Okay, so that's what this is binary output. Okay, so the multiple signals arrive at the dendrites and are then integrated into the cell body or nucleus. If the accumulated signal exceeds the sustained threshold, that is, the signal exceeds certain threshold, this point is covered by ANN technique called activation function. Okay, an output signal is generated that will passed by the axon. So here also same. Okay, so this is the comparison, guys. So summary is here biological neuron have multiple input signals received by the dendrites. Artificial neuron having multiple inputs. It's get from the input layer. Okay, then there is a cell nucleus, and here there is a neurons number of neurons having activation functions in the hidden layer, and axon 5 output signals here output layer. So this is the comparison between biological neuron and artificial neuron. So the neural network having a 3 unit input layer, hidden layer, output layer. Biological neuron having input signals, dendrites, axon 5 and output signals. This is the summary. Okay. Now the definition of artificial neuron. An artificial neuron is a mathematical function based on a model of biological neurons where each neuron takes input, weights them separately. This weight them separately is the artificial concept. Okay, sums them up and pass this sum through the non-linear function, that is activation function, to produce output. Okay, so just note, guys, this is the definition of artificial neuron. This is the I know what all we discussed in the last 10 minutes. It's a sum up with these 2 lines of 2 sentences of definition. Okay, an artificial neuron is a mathematical function based on a model of biological neurons where each neuron takes input, weights them separately, sums them up, and passes these sums through a non-linear function. That non-linear function you just put in bracket activation function to produce output. Okay. Any doubt, guys? Artificial neuron. Any doubts on artificial neuron? So as of now, what we discussed in neural network, there are 3 type of layers: input layer, hidden layer, output layer. Okay, the neural network is inspired by the biological neuron, human biological neuron. Okay, the comparison of biological neuron and artificial neuron we discussed. Okay, if you have any doubt, you can ask me, or if you want to teach me teach again, I will give the uh, uh, understanding explanation. Okay, if not, I will move. So this comparison, just note this point also. Biological neuron, artificial neuron, 4 parts. In the inside the neuron, there is a 4 parts, guys. I told 3 points, right? I told 3 points, but here they added input also. If you consider input, that is 4. Otherwise, it's 4. Node is nothing, it's a neuron or activation function. Node is activation function or whatever it is, the entire unit. Okay. Then input, weights, output. Okay, the consolidated points. This is the important, guys. If you understand these things, then the entire neural network is fruitful. If you not understand, then obviously you're not going to build a perfect model. You are going to build a model. That's all. If you want to build a perfect deep learning models, if you want to understand deep learning properly, this is the fundamental. You should be clear on your fundamental. Okay. Anyway, I will give the consolidated points. 7 points. In the 7 points, I will give the glance. So the first is a neuron is a mathematical function model on the working of biological neurons. Second, a neuron is an elementary unit and artificial neural network. Okay. So don't tell, sir, the neural network having a only one neuron. The hidden layer I don't know what is neuron and neural network. Okay, so each and every circles in the neural network is called as a neuron. Okay, in the hidden layer. So the first is a neuron is a mathematical function modeled on the working of biological neurons. A second point is a neuron is an elementary unit in an ANN or artificial neural network. And third is one or more input are separately weighted. Here you can see inside the picture, the glance picture, there are input received from the input layer. These are all the hidden layer units, x1 to xa, n number of neurons you can use. All the neurons are weighted, w1 to wn. Okay, so all the input values and weight values are summed up xi into wi formula, right? Summed up and passed through the activation function. Activation function we will discuss, don't worry, and output. So one or more inputs are separately weighted. This is the thing. Okay, inputs are summed up and passed through a non-linear function to produce output. So all the inputs are summed up and passed through the activation function. Okay, to produce the output. Every neuron holds an internal state called activation signal. Okay, so every neuron holds an internal state. Okay, so this is not an entire architecture. This is inside the neuron. Okay, just understand this is inside the neuron. For your understanding, I'm elaborated. Every neuron holds an internal state called activation signals. Each connections link carries information about input signals. Each connections carries a input signals about, okay, each connections link carries a information about input signal. Okay, and every neuron is connected to another neuron via connected link. Okay, so this neuron is connected to the another neuron, output layer or second hidden layer. You can use n number of hidden layer, guys. You can use n number of hidden layer. All the neurons are interconnected. That is the um, assumption here. All the neurons are interconnected. Okay, fine. And the second concept is perception, perceptron. Okay, so perceptron is a neural network unit or artificial neuron. Okay, that does certain computations to detect futures or business intelligence in the input data. So I will tell the perceptron clearly. Perceptron was introduced by the Frank Rosenberg in 1957. Artificial neuron is invented by McCullough in 1943. So later, 1957, Frank Rosenberg is a student of Walter Pitts. He evaluated the perceptron concept called perceptron learning rule. Okay, so nowadays I'm just telling the supervised learning rule. Okay, supervised learning rule, it's also comes from the perceptron learning rule only. Okay, so the problem formulations like this. Okay, so he proposed a perceptron learning rule based on the original MCP neuron. MCP neuron means McCullough-Pitts neuron. Okay, fine. So this is the perceptron learning rule. We will elaborate and discuss what is perceptron learning rule. So perceptron learning rule is nothing. Perceptron is an algorithm or learning rule for a supervised learning of binary classifiers. Okay, so you have inputs, n number of inputs associated with associated weights. Okay, so this algorithm enables neurons to learn process elements in the training set. Okay, so these input values are nothing but your training data. Okay, so this training data associated with random weights, these summed up the input and summed weights are passed through the activation function. Okay, activation functions. Then there are, okay, this is the entire perceptron, guys. So there are two type of perceptron: single layer perceptron and multi-layer perceptron. Okay, we will discuss what is single layer and multi-layer perceptron. Okay, so the perceptron rule states that the algorithm would automatically learn optimal weight coefficients. So just forget about this, guys. So optimal weights is ultimate aim of the neural network. There is a two concepts: weight initialization as well as optimization. Okay, that is the aim of the neural network. Okay, we will discuss weight initialization, optimization later. So this is for your understanding of the neural network. That's all. So n number of inputs, associated weights summed up and passed through the activation functions. These activation functions produce the output. Okay, I'll just take this image and explain clearly. You'll understand. Jamboard. Okay, so just assume you are going to pass one set of data. Um, Say for example, one iris data set. Okay, of any data set. Okay, suppose this is the data. I'm just taking any iris. You are all familiar with iris data set, right? So you can say these four values. Okay, so just understand, guys. I don't have any additional equipments, so okay. So this is the iris data set, guys. You can see here. So based on these four parameters, I can able to tell whether this space is a Setosa or some other classes. I think four classes are there: Setosa, Virginia, some two classes are there. Okay, let's see. Versicolor, Virginia, Setosa, three categories. Okay, so based on this sepal length, sepal width, petal width. Okay, sepal length, sepal width, petal width, different measurement of the leaf, leaf of the iris flower. Okay, see this is the sepal, this is the petal. Okay, this length and this length. Based on the sepal length and petal length, we can able to classify whether this is a versicolor category or setosa category or virginica category. Okay, so this is the iris data set problem. Okay, suppose I am passing these five values. Okay, 5.1, 3.5, 1.4, 0.2. Just they say for the mathematical notation, setosa is 0 and versicolor is 1, Virginia is 2. Okay, just assume this is not a Setosa, this is not this is versicolor and this is Virginia. Okay, right. So I'm going to pass this four data into the neural network. 5.1, 3.5, 5.1, 3.5, and what else? 2, 1.4, 0.2, 1.4 and 0.2. So this is four data I'm going to pass into the neural network. Okay, so here 5.1, here 1, 1.3, sorry 1 in here, so 3.5, and last neuron having a 0.2. Okay, so the four values I passed into the my x1 to x4. Okay, I'm passed in my input layer, and weights are randomly assigned. Okay, there are different type of weight initialization techniques we will discuss in the execution of the neural network. For right now, we just assume the random weights. Say for example 0.1, 0.2, 0.3, and 0.4. Okay? So forget about this bias. Okay, don't take this bias. Okay, let's take this as a x1, x2, x3, x4. Weight 0, weight 1, weight 1, weight 2, weight 3, and weight 4. Okay, so four inputs, four weights. Okay, so now this 5 initial weight is 5, right? 5 value 5. 5 is multiplied with 0.1, right? 5 is multiplied with 0.1 plus, and this 1 second value 1 multiplied with 0.2 plus third value 3.5 is multiplied with 0.3 plus 0.2 fourth input value is multiplied with 0.4. Okay, so this is the formula which we discussed earlier, right? Summation of xi into wi. Okay, perceptron learning rule. Okay, perceptron learning rule formula is sum of xi into wi. Okay, so here I is equal to 1 to 4. 4 inputs I have. So x1, x2, x3, x4. Okay, and this is w1, w2, and w3, w4. Okay, give me a minute, guys. Manager calls me. Give me a minute. Give me a minute. Sir, சொல்லுங்க சார். சார் சொல்லுங்க சார். Sorry for the interruption, guys. Okay. So all the inputs are multiplied with the associated weights, okay, and passed through the activation functions. So for example, my activation function is ReLU, okay, linear rectified unit. We will discuss later, ReLU, okay. So this value is x axis value in the activation function. Say for example, this value is let's say it's a 3, okay. I don't know what is the calculation of this value, but let's say 3, okay. The associated y is 3, but different activation functions are there, okay, right. The associated y is 3, so this 3 will go here, okay. Say for okay, just take this as a 0.4, okay? 0.4. Also here also 0.4 output, okay. Suppose my output is 1, okay. I know I know this data set, right? So this is a supervised learning problem. The label is 1, okay, but you got only 0.4, okay. So the error is calculated. 1 minus 0.4 is sent to the weight units, these units, okay. So for the second iteration, the input value is same, but the weight is going to updates. Instead of 0.1, it's going to update 0.2, 0.3, 0.7, or 0.8, like that. It's going to be updated the weight. So then next iteration, the same process, you may get this 0.6. Okay. Now also there is a error, 1 minus 0.6, there is a error called 0.4. Okay. So based on this error, again the weight is updated. 0.3, 0.4, 0.7, 0.9. See all the updated weights. Now the same process is going to be happened again. Now 0.9. Okay. Now again also when until unless it reaches 1, it's going to be updated. So when the value is exactly same with the label, then that rate is considered for the training. Okay, for your training. So this rate is used to predict the next data. Okay, suppose next the value is input is not 5, 7. Okay, just I will move to the next slide. Okay, just take the copy of the slide. I will clear this. Okay, so this is the initial weights. Okay, this is the initial calculation. After many iterations, after training, we will get updated weights. Instead of 0.1, we will get 0.7. Let's say here instead of 0.2, we will get 0.6, and instead of 0.3, we will get 0.4, and instead of 0.4, we will get 0.9. Okay, so this is the updated weight. Okay, now this weight is going to predict the few new values. Say for example, this is your training value, right? This 5, 1, um, you know 3.5 and 0.2 are your training values, right? Now the future new value is 4, and instead of 1 it's 2, instead of 3.5 it's 3.2, and instead of 0.2 it's 3.1. Okay, so based on the input, the new input is going to multiply it by the updated weights or update weight by the perceptron learning rule. This is the weight update. This is the weights gained by the perceptron learning rule. Okay, so the perceptron learning rule produces the optimal weights. So this weights is multiplied with a new set of inputs, and it's going to calculate whether the new input is Setosa or versicolor or Virginia. Okay, so this is how the neural network is used to predict or classify the classes or classify the data. Okay, any doubt, guys? Guys, any doubts? I know if you may not understand, but you know, okay, I will suggest some books. Okay, you have to go through it. Note this book, guys. The book reading is very important. Okay, so the first book is very basic book, that is introduction to neural network by S.N. Deepa. Okay. He is the greatest professor, worked in PS Engineering College, I think head of the Department of Computer Science. He is a deep learning researcher, S.N. Deepa. Okay. So this is good book. And second, if you wanna, you know, the standard content, the good book is Hans Deep Learning with Python by Roncois College, and hands-on machine learning with scikit-learn by Arlene Jaron. I don't know the spelling, guys, but you may get. Okay. This is the three books, useful, very useful to learn the neural networks and deep learning. All the concepts available for all these three books, but the first book is different. First book is entirely concept oriented. That you may find some neural network problems. If you are preparing for the GATE exams for your PhD, definitely this book will help you. Okay. Um, there is a s- there is another one book by a same author called Soft Computing. Okay. Soft Computing and Fuzzy Logic by S.N. Deepa. So this is also a good book to grasp the GATE examinations or NET examinations concepts. Right. Okay, so this is the standard book, guys. So you have to follow these three books. I have the e-copy. Definitely, I will upload it to the Google Classrooms. No issues. So you have to follow these three books. If you want, I will show the three books also, guys. I have that. Okay, so this is the not this one. So this is the deep learning with Python book by Francois Cholet. So he is the developer of, he is the head of machine learning in Google. Okay. So this is a good book. So you will get the practical understanding of deep learning and neural networks, fundamentals of machine learning, and what is the difference between machine learning and deep learning. Of course, deep learning is a subset of machine learning, but you will understand the different set of problem framings. Okay, then especially for how the deep learning is adapted for the computer vision, image task and text task, and some advanced deep learning models, generative deep learning models, GAN algorithms, autoencoders, everything you will get by the. There is a code examples as well as conceptual examples. Everything is available. Definitely, I will attach these books into the classrooms. And some other books are there. I don't know where is it. I'll just show in the internet also. Okay. So hands-on machine learning with scikit-learn. This is the book, guys. Um, by Arlene Geron. Any chats? What Google?
Sir, can you put all the book names in chat, sir?
Yeah,
Thank
sure,
you.
sure, 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 sure. So this is the second book, Hands-on Machine Learning with scikit-learn. So here, this is the Bible of your artificial intelligence students, guys. This is I'm definitely recommend this book for you. You will definitely there is a um, this is the Bible, guys. All the units available. I have the book actually. Yes, what exactly the book is. What is it? It's a bit, and I will share you guys. I have e-copies. I will definitely share with you. But this is the book. Is a Bible. The topics are from scratch itself. It starts out with the linear regression to GAN models, advanced GAN models, and deployment also available. Okay, that is the advantage of this book. Okay, if you definitely recommend this book to purchase. Okay, you can purchase this book also hard copy. You must have this book. I don't know where is the index parts. If index parts finds, I will definitely explain. So it starts from the machine learning landscape, fundamentals of machine learning. I think here it's index. Yeah, you can see here the index is available here. It starts from the fundamentals of machine learning. Okay, so what is machine learning, what is the use of machine learning, underfitting, overfitting, then end-to-end machine learning project approach. Okay, then classification, regression, how to train the models from linear regression, logistic regression, gradient descent algorithm, SVM, decision trees, ensample, dimensionality detection, then neural networks, introduction to the artificial neural networks, okay, multi-layer perceptrons, so biological neurons. So all the things I presented here, I took from this book only. Okay, don't worry. So if you follow this book, definitely you will understand my lectures. Okay. So if
Sir,
you not, yeah,
can you recommend book for Transformers?
um, Transformers. I don't know. I will recommend the documentations. Transformers is still in research area. Multiple books available in the ORLE and PAC publications, but I would not recommend that. But if you want to understand the Transformers, you can go to the documentations, Keras documentations, or TensorFlow documentations, and you can learn reference papers. Okay, definitely I will give the reference papers. Don't worry. Um, but I don't know the books because Transformers always in nowadays there is a no standard book for Transformers. If you want to learn practically, you can go to the packed publications, okay, or OEL publications. But there is a no standard authors. And I will search by end of this course. Definitely, I will recommend for you the Transformers also. Okay, and I will give some research papers you can read. Okay, is it okay, guys?
Okay.
Yeah, yeah, yeah. Even GAN also, even GAN also there is a no standard books. Okay, so there are for GAN there is a one GitHub page. I will just share the GAN page. Yeah, here you can see the GAN Jew. Okay, so you can see here there are variety of GANs. Okay, so one researchers are putting a ABC GAN, then second researchers find out there is a error in B, so there is a AC GAN. So like that, there are variety of concepts. So you can see still in research, multiple GANs. Okay, so we need at least 4 to 5 years to understand all the researches. So it will take another 5 years to 5 years for uh, definitely it will take another 5 to 6 years to come up with a new standard books for the GAN and transformers. Okay, I'll just share the GAN do also, guys. So just see that this is the power of deep learning. Okay, there is a no standard, so there is a lot of implementations. Okay, don't worry, I will give the transformer recommendations definitely. Okay, so I will just check with the Google Scholar and find out the optimal tutorial, and I will share with you. Okay, fine. So this book is a Bible, guys. Hands-on machine learning. Just come up with these things. So computer vision, RNN, CNN, natural language processing, auto encoders, GANs, reinforcement learning, and deploying. This is the important part. Of course, the degree level students, master level students, and bachelor level students are not able to get the deployment part into their syllabus curriculum. And some students, some extraordinary students, are learned from their own, and some students are finding difficulty to deploying the model, or finding tutorials to find the how to deploy the deep learning models, hardware difficulties. So if you have these difficulties, definitely this 19th chapter will help you, guys. This 19th chapter will definitely will help you. There are 50 pages. These 50 pages will definitely help you to deploy the successful deep learning models. Okay, that's what I'm saying. This is a Bible of the AI students. Okay, fine. And third book is, we will go to the third book. Um, Neural networks by and Sivanandam. There is another author, Sivanandam. So this is the book, Introduction to Neural Network. Okay, so here, I don't know, many people are not using these books, but I recommend it. This is a good book. No, IITians and non-university students are using these books. This is concept-oriented books. Yes, if you are having any doubt on the concepts, perceptron, weights, optimal weights, error calculation, so this book will definitely help you. I'll just show the image. Okay, this is the book. This is the book. 880 rupees in Amazon. Um, there is no index page. I don't know. So this is the book. S. Sivanandam and S. N. Deepa. Introduction to Neural Network using MATLAB. Tata McGraw Kill publication. Okay. You can find in the Moore market. So if you have money, you can purchase from the directly from the Amazon. Or if you want to, if you're not able to spend 80 rupees, you want to only spend 200 rupees or 150 rupees, you can go to the Moore market, the hard copy available. Otherwise, definitely I will update the soft copy of this book within by tomorrow. Okay, by tomorrow I will update all the books in my classrooms. Okay, so this is the three books will definitely helpful to the neural network guys. Fine. So okay, so I demonstrated so how the neural network is how the perceptron learning rule is used to find out the or predict the classification or predict the classes um, based on the available training data set with the example of iris data set I demonstrated. I will definitely give the software implementations also, don't worry. Okay, so this is the initial level of understanding of neural network guys. Okay, so next, so what we discussed, which is elaborate